One. So the question for everybody is here. Do we have new faces or new one? And I think you all were there for the previous class, right? Okay. So what were we doing in class? Derived quantity and yes, fundamental quantities, derived quantities, and what else did we do? We did some kinds of units, CGS units, SI units, right? So, and MKS units. Okay. So a quick recap. Give me one example of fundamental unit. Fundamental or kilometer. Okay. Which is the quantity that we are talking about here? Which is the fundamental quantity? Distance. Okay. Give me one example of derived quantity, please. Derived quantity. Are you saying meter or meter? Everything sounds the same. Meter. What is she saying? Meter. Meter is fundamental quantity. It's unit of fundamental quantity. Centimeter. What? We're talking. We should do everything again. Then. Fundamental quantity and derived quantity. What is happening? Yes, please. One example of derived quantity. Area of volume. Area or volume, right? Yeah. Area of volume. So these are all what this requires formula. What is formula for area? Side. Yes, it's side into side. What is formula for volume of a cube? S cube. So this is derived from fundamental quantity. What is side? It is nothing but length. That is one fundamental quantity. Give me another example of fundamental quantity. Side, yeah, that's taken by her. Anything else? Fundamental we are talking about. Temperature and we will talk about how like mass. Yes, mass, kg. That's not weight, but yes, mass. We don't say weight and mass are two different quantities of physics. Okay, so yes, what? Light is something. It's intensity of light. This yes. So candela. Yes, candela is unit. There are different other fundamental quantities which are not aware of the textbook has given. You can go through them and learn, but of course we can't go into what exactly that is because this is not the age book that you would be knowing. So we'll go to the other important part. Yes, please. SI unit, CGS unit, and MKS unit. Full form of CGS unit? Centimeter, gram, second. Full form of give me SI unit for distance. SI unit is SI unit, please. I've given you the hint. SI unit, yes. SI unit is what? It's meter, please. It's meter. What is SI unit of mass? kg and SI unit of time? Second. MKS, please do not forget that, please. It's very important. What is full form of FPS? Full form. Second. S is everywhere second. Okay, what was the other one? I think we are done. There was something known as I did give you. I asked you to remember few things. If I say micrometer, what does micro mean? Who do we have in participant? Yes, micro meter. So if I want only in terms of meter, so micro is 10 to the power what? Micro. -6. Yes. What is -3? Nano. No, that's -9. Nano is -9. Okay. Yes, 10 to the power -3 is what? Milli. Okay. And what else did I ask you to remember? Yes, giga. Giga, please. You can also answer if you know. Gita is minus. Gita is used.
10 to the power 12.
15, 16. 10 to the power 9. 10 to the power 6 is what? Mega. It's mega. Okay. And I did speak about light year. What is light year?
Light year is the distance traversed by light
In a year. Okay. So what is speed of light in terms of second? We know, right? If you remember, speed of
1
light.
into 10 power 3 meter per.
This at least you should remember. Some part that 3 into 10 to the power 8 meter per second. This is speed of light in just 1 second. And just imagine how much light can travel in 1 year. Okay. We did all those conversions. And what did we do? We did parsec. Parsec. Did anyone remember what is parsec?
to measure the distance between
Yeah, at least you should remember it is a unit of distance, okay? And that is for celestial bodies. And we used something called semi-major axis, if you remember. This is sun, this is earth, and it orbits in elliptical path. Then this is your semi-major axis, and this is your semi-minor axis. So what was parsec? Distance of that star from the semi-major axis, okay? When it makes what degree angle?
90.
What degree angle it makes? I told you to break parsec like this. Par is for parallel. Sec is what? Second is what? Time. It's time. I told you last time this second represents angle. This is 1 second. I stressed on this part so much last. Did I or did I not do this in this class? We did this, right?
Yes.
We did this. I told you this is 1 second. Okay. In angle also 1 degree is equal to 3600 second. We even did this part if you remember. But then this second is not time second, although it has 3600 only. But this 1 degree is, so this 1 degree angle which we see in our protractor, if you break it in 3600 parts, then one of this one simple one will be your 1 sec. Okay, that one out of 3600 will be your second. Okay, so 1 second will be equal to 1 over 3600 degree. So it's okay. I know this was the toughest part, so I can understand if you have forgotten this completely. But then a bit of revision every time I'm going to do at least for parsec. Distance from semi-major axis, okay, and what angle does it subtends? 1 second or 1 sec angle is okay. We are moving to another important part today. We'll be doing 2 devices. Vernier caliper. I am not aware if you have heard of this device. Have you, or have you seen or used it? Okay. So this vernier caliper is, I wish I could show you an image of this. Okay, I'll draw it and then show you the image.
One image is
It's there in the textbook. Okay, you can see the image in your textbook. So this vernier caliper, we were talking about measurement. This chapter is all about measurements, right? And this measurement, when do we do measurements? When we are doing some experimental thing, and in which measurement plays an important role. Even a small error can result in a huge problem in what we are dealing with. So measurement has to be accurate. So if, in case you are asked to measure this length of cable, what will you use? No. Which device that you have that you can use? Right now, ruler, measuring. Okay. Right now, what do you have? Scale. Okay, I am giving you 1 task instantly. Can you give me measurement for this? If you have a scale, give me measurement of this. I'll see how different are all of your answers quickly. 21. I want accurate as you can. 26. 21 making 26? 26.5. 26.5.
26.8.
26.8. I want the answer today. What's the answer? Okay, I think I take the third one from any one of you will start. 25.5. Okay, one thing that you
26.8.
okay, good. So one thing that you noticed is this thing. Let's say if I say that the measurement is 26.893. Can you take this one as the answer?
26.6.
No, my question is I have written this and I have added one more. Okay. Just imagine I have also used this ruler, same ruler, and I got this one. Can I get this answer?
No,
Why can I not get this answer?
because in a
Because,
scale it only consists of meters and there.
Yes, so what she means is the smallest unit that I have, it's not let's not worry about that. So never be. Yes. So if you check your ruler, you see that there is 0, then there is 1 centimeter, and then this is broken into how many more parts? 10, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So you have like 0 and 1 further broken into how many parts? 10 equal parts, right? And this smallest one is how much? 0.1, right? And which is this largest one? It can go to 0.9 and then again it becomes 1. So what happens? So what happens? I can go up to this decimal. I can go smaller than that or smaller than that. Do I have measurements for 0.001? Can this scale of mine measure 0.001? Can this scale measure up to 0.01 also? No, this is smallest is how much? 0.1. So how can my answer go to even smaller than that? Okay. So what does this mean? That in my scale, in the scale that you are using, my smallest count, and we call in that thing we call it as least count. What do we call it? Least count. If you see LC in your textbook and in any experiment that you do henceforth in higher grades, you will see. So please be careful. You will see this word called LC, which is least count. So what is least count of my ruler? The least count of my ruler is 0.1 centimeter. Is 0.1 centimeter. The least that I can measure through this. And if sometimes they write 1 mm. Am I wrong or not?
Correct.
I am correct. Okay. I just changed my unit. 1 mm is nothing but 0.1 centimeter. So do not get confused with this. Is this clear? So this, the smallest one is called LC. And this one, this is nothing but my main scale division. This is my main scale division. So what we see here, that to measure length using this ruler, I can measure it up to this. My smallest distance that I can measure is 0.1 centimeter. If I want to measure something more accurately, and if I want to go a further step ahead of that and measure the smallest distance as possible as 0.01 centimeter, we use a device called vernier caliper. Even smaller than that is also possible if my vernier caliper is designed in such a manner. So what is vernier caliper? It is a device which measures what? It measures length. Okay. And so how different is it from this thing that we are going to study? Before we check everything of that, we will quickly check its diagram. If you have book, please see how it looks, and I will try to replicate with my diagram. It may not be as nice. I hope I can give you a good picture. what happens? Is someone saying something?
No, ma'am.
So this is the device. It's called vernier caliper. There is normal ruler kind of the calibration that हम हमारे ruler में देखते हैं. The same kind of calibration we see on one part of this. Okay. Apart from that, there is some another smaller set of scale. We call this as VS. We call this as vernier scale. Okay. This one is our normal scale, our ruler scale. So we call this as main scale. And this is vernier scale. Okay. This is the main longer jaws are called external jaws. They are called external jaws. And this is inner jaws. Yeah, inner or internal jaws. Okay, this is external. And there is, I don't know if your diagram has it or not. There is something like this also which comes out.
There it is written inside or outside.
Yes, it's fine. Inner and outer, or inner or external. You just need to understand the English terminology. They won't ask you this thing. That's not the major part. You have to go to major part. You see this kind of thing also as you move this part away, this will go on extending. I know this diagram or my diagram, it's not clear. I will try to see if I can show you with the image which is to each other near caliper and what?
If there's an image.
No, it won't take much time. Yes. Yes, can you just see and pass it? Just see how this jaw is moving. Okay. See it and pass it. You don't have to analyze it. Huh? If you can see it, it's fine. So you see that this part moves, and if you want to measure the length of object or thickness of object, you can keep that object over here, okay, and you can move it so that it you can see the measurement over here, okay, and if the length is slightly more, you can draw this outside your sheet moves, okay. And you see this scale, main scale, and everything. This outer jaw is used to measure the length of the objects which are very easy to find. This inner jaw is actually used to measure the inner diameter of a hollow object. Just imagine if I have hollow object, okay, this is hollow, and if I want to check the inner diameter, so I can, it is difficult to put those two bigger jaws inside, okay, that can only do this thing. So I use this jaws to use the measure the inner diameter. And this one length, this moves as you move this outside and inside. This is used to measure the depth of the object. Depth is nothing but again length, right? So this whole device is used to measure length, be it radius, be it length of the object, or be it depth of the object. Is this clear? So now how main scale, vernier scale, and this device helps us to find the accuracy of 0.01 LC. This is what we are going to do. Check 0.01 LC, what in terms of centimeter. Okay, we will see that. It's in case. Sorry,
0.1 millimeter. You could also say.
Yes, or I can also say 10 mm. I can say 10 mm.
0.1.
Yes. Where? Okay, so this will have lots of calculation, lots of confusion. If you have any confusion, please clear it then and there, because these are experimental skills. This will be with you for higher grades. Okay. So let's say I have placed my object, my jaws give me some reading. Okay. And how do we measure in this thing? The vernier caliper has some zeros. It has 0 and it has 10. Okay. What does this mean is that my vernier caliper my vernier caliper is divided into 10 smaller parts. 10 smaller parts. Just check how many are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This is my vernier caliper part. And this is overlapping so this thing overlaps on my that main scale jaw. You remember there was main scale jaw. So main scale lines were like this is 0, this is 1 centimeter. Let's say there is 2 centimeter over here. Let's say there is 3 centimeter. Let's say 4 centimeter. Something like this. Okay. What happens in this case? This 1 centimeter, and you see there are small vernier caliper sections. Let's say I have zoomed my image and next class I think I'll have so that I don't waste my time in drawing. Pay attention what changes I am making. So we're going to ask you on this part. This is my 1 centimeter. Okay. This is my another 1 centimeter, and likewise it goes. And on this main scale, my smaller vernier scale keeps moving. Okay. So at this point where my object is of this length, let's say my zero of my vernier caliper is exactly matching on this 1 centimeter point. So my measurement, how do I measure my object's length? My object's length measurement is done by this as a reference point where 0 vernier caliper is pointing. Is that clear? Where my 0 vernier caliper is pointing. Like if you measure, right, your scale is already there, but there has to be some reference point, right? Which is okay, this much is the length. So if my object is like this, and when I move my jaw, this main scale is still fixed, right? What moves is this jaw moves my vernier scale. What is happening? Are you getting what I'm trying to say? So what happens is, so initially when there is object, where will my vernier scale be? It will be at 0, right? Right? There is no object, everything we are completely together, right? So it will be at which position? This vernier caliper will be at which position? 0. Is that clear? And now when I am an object, I'm moving this jaw, and as I move the jaw, the main scale is behind, it is fixed, and my vernier caliper starts moving and starts giving me the distance. Now it is stopped at what? 1. Is this clear? Right? But what happens if it is at 1? I get my answer as 1 centimeter. No. Okay, this is just a special case where I got this. But what I am looking for is more accurate measurements in terms of 0.00, right? I'm looking for that. So what happens is, in that cases, sometimes it is not as easy as it looks. What happens is, my 1 stands here, okay? My 1, and my next, after 1, from 1 to 2, how many parts are these above ones also divided into 10? So now I will draw them as well. So let's say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, And are they 10? Just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10. So now please pay attention what we are doing. So now what happens that in previous case, oh, I was lucky that my 0 overlapped with 1. But not every time that happens. Okay. Sometimes my 0 might stop at some place which is in between this 1 and 1.1. Are you getting that? In that case, how will I do my measurement? Since it is not 1.1, it is less than 1.1. So which one will I choose on main scale? My main scale reading is what? 1. So I choose my main scale reading as 1 centimeter. Okay. And to go the 2 steps ahead, beta, pay attention. This is really important. I know. Is she also new? Okay. I know that is why it is becoming difficult. But then this is main scale, like your ruler, and this is the vernier scale. This part is important. So this is clear how we got 1. How we got 1 over here. Now we will try to find out the accurate measurement because this is slightly more than 1. I don't know if it is difficult, but it is slightly okay. So after seeing this, that I know 0 is not overlapping, so I will check which one of these lines are overlapping. Okay, if they have made this device such that one of this line will overlap somewhere with the above one. Okay, let's say in this case, it is this one. It overlaps exactly over there. Okay, are you getting what I'm trying to say? You have to see and you see that they both are in straight line. They overlap exactly about each other. They are not like aage piche in this case. Okay, this is here, then this is in between. They are not together. But at one place they overlap each other. So I then choose that point. So how much is this? This is 1, 2, 3, 4, 5, 6. This is the 6th part, 6th vernier scale division. So I say it is the 6th vernier scale division. Okay. And my vernier scale 6th division, I will add to my initial measurement 1 centimeter plus the 6th division multiplied by this vernier caliper's smallest division that it gives, like in normal scale, what is my LC? In scale, what is my LC? 0.1 centimeter. You told me just now, right? In this one, vernier scale's smallest division that vernier caliper gives is 0.01. So my final answer is 1 centimeter plus this. So it is 1 plus 0.06. So my answer is 1.06 centimeter. I get accurate up to 2 decimal points. Is this clear? So now you would ask, okay, how did I get this 0.01? For that, we will have to study the whole formula thing which your textbook has given. Okay. So we are going to do that. It has some formula into that. If you see, there is something called x by x minus 1 upon n minus 1 or something like that. If you see that part. So we are going to move to that part. But before that, is this part clear? How to take measurements? You see main scale. If main scale and 0, the initial point are overlapping exactly, then of course that is the answer. But that doesn't happen most of the time. Okay. If it is slightly ahead somewhere, then we'll check which of them overlap. Is that clear? And the ones which overlap, we do not say which of the top one overlaps. You will not check main scale 1, 2, 3, 4. No, please don't do that. We will check which of the vernier scale line overlaps. Okay. And then we will multiply that by 0.01 and then add and get the final answer. So how and why do they do that? So the formula goes like this. So LC is x by n. That's the formula that they have given. Do you see that? That x is the smallest main scale division. We view there is 1 centimeter, there is 2 centimeter, there is 3 centimeter, there is 4 centimeter. And what is the smallest main scale division of vernier caliper? Same as your ruler. How much is it? Not 1. That is.
0.1.
What is the smallest main scale division? 0.1 centimeter. This main scale of vernier caliper and your ruler is same. Okay. So X is how much? The smallest division is how much? The smallest division is how much? 0.1 centimeter. Okay. This N I write smallest. Smallest main scale division. Okay. What is N? N is number of vernier scale divisions. And I told you vernier caliper has how many divisions? 10. This one, okay? It might happen that they can divide that one into 50. Then in that case, your formula would become 0.1 by 50. In my case, how many were that? 10. So, what is the answer? 0.01 centimeter. Right? LC is X by N, and my X was 0.1. My N was 10. That is how I got 0.01. Is this clear to everyone? Okay. How we got X by N also we will do, but it is taxing. I know already this has gone beyond your head, it seems to me. So I want to do some questions. We'll get the knack of it and then see how even X by N came, in case you are curiosity how that came. So solve one answer for me. Do you know Selena with you? Okay, otherwise, you have Selena. Otherwise, you can solve this one. Which one will you prefer, this or Selena? Okay, so let's check the 25th question. It has a vernier caliper's main scale and vernier caliper, and after placing some rod and all, they have given a snapshot of the part. Okay, and you have to tell me what is the measurement of the rod. They have not shown you the rod and everything, but they have given you the snapshot. You need to tell me what is the question number 25. Yes, what is the page number 11, question number 25. So you have got something like this in your diagram, and they have given main scale, and they are given, and they are asking what is the length of, like he questioned what is the length of the rod, but length rod ही किधर है? So this is part of a vernier caliper which has a rod placed, but instead of giving the whole diagram, then this will look so small. They have just said that they have kept one rod, okay, on vernier caliper, and you know that since rod has been kept, this vernier caliper part, the VS part, will move from 0 to somewhat aage, because here there is 0, then there is 1, there is 2, then 3 and 4. This has to be really huge also. Just see my 3 and 4 is like this. So here 2, here 1, here 0, and then somewhere here that rod is kept. Are you able to imagine? They have just given you the zoomed out image of that portion which is required for what? Measurement. What did I say? As you place the rod, this vernier section will move measure the rod, what was the first thing that you should check? There is my vernier calipers 0 coinciding. There is vernier calipers division given 0 to 10, right? What was the first thing that I said? Check where is 0, right? Is it on 0? Then the length would be 0. Is it on 0? No, it is of course it's gone ahead, and somewhere here. So length is how much? My main scale reading plus my vernier scale reading, right? We have to give main scale part. What is my main scale part? Where is it coinciding? Please check your diagram now. There is my 0 coinciding exactly at 3 or 3.1 or 3.2 or 3.3.
3.4.
3.4.
And 3.4.
Let me check the diagram so that I will check all. So I will draw it with some other color now. So this is my yes, the green one, and okay, see what smartness they have done. They have put it like no, let me just draw it so that you understand. They have done something like this, okay. This is confusing. I know this is the most confusing part, but the diagram has confused you even more. It's good you get confused today, it's fine. And so I am not drawing the inner ones because it will be very difficult for me to copy. Okay. So this was my main scale, this vernier caliper, this vernier caliper 1. This is moving across, and we always refer this VS vernier scale. There is my 0 of vernier scale pointing. That's the first thing that we see, right? There is my 0 pointing, 0 of my vernier scale. In this case, they have got some outer box also, which is pointing at, pointing somewhere between 3.2, right? And they have pointed this 0. What did we discuss in your diagram? If there are some extra squares or everything, you have to ignore that. What is my reference point? 0. And where is my 0? My 0 is after 3.1, 3.2, 3.3. Okay? It's at
3.3 and
of course it is between 3.3 and 3.4. But can I take 3.4? No, because of course I can't take extra. I can take less because then I will add ES part. So I will take the lesser one. What is that? 3.3. So my main scale reading is 3.3. I hope you got the answer why 3.3 and not this one. They have just drawn some extra squares. Okay, it's just an extra square. That's the first thing. If you have understood how you got 3.3, let's move to the next part. In this case, only you can help me because I can't replicate the diagram which is there. Tell me out of these 0 to 10 which they have drawn, which one exactly overlaps? 5th division. Okay, 5th division of the vernier caliper. Let me see further.
6th division.
6th division. Yes, 6th one. The others check.
And this one.
Even the plan is that one.
Let me check it. One of you are done.
And this one.
It's a bit too long.
You said 6th one or 5th one? Okay, it's mostly the 6th one, but it's okay. It's not your part. it's not a point, I'm sorry. It's the problem with the printing of the diagram. In examination, they won't do such inaccurate. So we'll take.
Here it's not a printing mistake.
You can take Selena. I think Selena would not even printout which will have such a problem and give the answer for that. At least you got how to find it. Let's presume next one. Let's presume it's this next one. Then we say 6 multiplied by my least count.
0.0.
3.3 plus 0.26. My answer would be 3.3. Is this clear to you?
Yes.
Please take the Selena book.
No, the rod.
Length of the rod. Take Selena book and that be quick. Give me the answers. Check where is the 0 point. Get the main scale. Check which vernier division is coinciding and give me the answer. Quickly. Don't have Selena book? Who has Selena? Only 1, 2. You have Selena? Please give 1 to 4. Or you can share with them. No? You have Selena book? Okay. Girls, you can share here. So let's share here. You both share and you can share. You can come here and discuss. At least for this question, you can come here and quickly check what is main scale. Yes, page number 11 and the one which they already have given as example, we can take that as well. Yeah, answer for this. No, that diagram is not for the measurement part. Yes, take. Yes, over here, no, wait. Can you all wait? Page number 11. Page number 11. There is this diagram. Can you see the diagram?
Yes.
Okay. Can you see there is one main scale which is written downwards and one vernier scale which they have written movable, and there is some coinciding part given. For this one, can you tell me length of the rod, please? 1.2 image. 1.2 image. 1.2. And do not turn back the page and look for the answer. Okay. Tell me for the main scale part at least, where is the 0 coinciding? Main scale. What is my main scale? What is my main scale answer? 1.2, 1.4, 1.2. The main scale answer. Which is 1.2. 1.2. Okay, my main scale is 1.2. And which vernier scale division is coinciding? Everybody says 4th one. Are you sure the 4th one is coinciding? Is that the 4th vernier scale division? For the 4th one? Okay. So, 4th one into 0.01. My answer is 1.24. You can turn back your page and see they are also giving 1.2 for an answer. I think that example is there for that. They are given. Okay. So, is at least measuring your caliper clear? To an extent, it is clear because now we are moving to even tougher part. Shall we? Okay, the next tougher part is and you see in this all diagrams, it's up to the person who's asking questions. They draw it vernier scale as their own way and main scale as their own way. So in this diagram, they have like another box outside, and in the question they had given your main scale and above vernier scale. So it is up to your examiner in which way he has to draw the diagram and give it as question to you. You need to be clear in your mind that the above one has a fixed number of divisions, that is vernier scale, This is my main scale. I have to refer the 0 point of vernier scale. Okay. So in whatever way they give the diagram, it should not confuse. So we are going to the tougher of this. So what is the tougher one? I already told you that this was my vernier caliper, and you keep that object between the jaws and meshes, right? But if nothing is kept in between, if nothing is kept in between, then my main scale is at 0 and my vernier scale should also be at what? 0. They both should coincide, right? Right? Because this is my start, right? There is nothing kept inside, they are put together. Then 0 of main scale should coincide with 0 of vernier scale, right? What happens now? Henceforth, I won't draw all of this. I will also use the way Selina is doing. The above one will be main scale. Whatever I draw above, the below one will be vernier scale. Okay, I'll draw it. But what happens in reality? All these instruments are not that well polished. Let's say sometimes there is more. This jaw is slightly thinner on this edge. So what will happen? It will get pushed slightly further. So instead of coinciding on this 0, this vernier scale 0 will go slightly ahead. Are you getting?
If we measure anything with that, if this coincides, then a measurement would be enough for it.
Yes, exactly. So this is what we are doing with the error part. So since ideally my 0 of main scale and my 0 of vernier scale, this position, in this condition, it should be coinciding. Then only, this is my initial position. Then only if it moves 3 meters away, 3 centimeter away, I can say, oh, okay, measurement is 3 centimeter. But what if this one was faulty and instead of coinciding here, it was slightly behind? Okay, we have, and this is my 10 divisions. It went slightly ahead. Result in some error, right? Sometimes it may happen that instead of going back, this one was slightly extra built. So instead of coinciding at 0, it will be slightly ahead. My 0 is ahead, my vernier scale 0 is slightly ahead. So what is happening in this case? Let's see if the 0 was ahead. So every time I gave measurement of 1 centimeter, I was actually saying that it is 1 centimeter, but was it 1 centimeter? No, this extra was taken, which was faulty. This extra was taken because this had already an inbuilt error of something, right? Right? So it had some error, and when we are giving something extra at the beginning itself, because there is extra, right? It has already covered this much distance. Let's say this was 2 divisions, 0.2 divisions of main scale. So every time, exactly. So what it does is, every time this kind of faulty instrument, the 0 is ahead, this kind of instrument will give you extra measurement. What you have to do for such kind of measurement? You have to subtract it. Are you getting? So we call such kind of errors where it is ahead of the 0 of main scale, we call this as positive error. But what do we as positive error? For final answer, we subtract them. What do we do? What I'm trying to say. Let's say it was ahead by 0.2 centimeter. So what is my error over here? It cannot do, but then let's say, okay, my error is 0.2 centimeter. This is my error. This much huge error is there, 0.2 centimeter. And after measurement, I saw that my answer is coming as 3 centimeter. Okay, is my answer actually 3? No, it should be 2.8. I have to do the final answer. So final answer is 3 centimeter, which is by measurement. And what kind of error is it having? Positive error. In that case, we are positive in the sense extra. We are giving something extra. So I'll subtract this 0.2 and my actual answer will be 2.8. Okay, and like she said, in negative error, what will happen?
It would be
In negative error, this poor fellow who was, let's say, since this is it was 0, let's say it was 0.25, 0 is overlapping here. So what happens when it was giving me measurement of 3 centimeter? Had it traveled 3 centimeter? It had actually traveled more than 3 because itna to बेचारे ने पहले ही कर दिया था, right? So in case of when it is behind, though we call it negative error, we call this as negative error. We write it as -2, 0.2 centimeter negative error. Okay, but for the final measurement, we add that and my answer is 3.2 centimeter. Are you clear with what is happening? Which one is positive error? Which one is negative error? If a diagram has, we'll check your diagram, but you will get to know which one is which error. So this one I randomly gave you top numbers. It is not given directly. You have to again check how much is the error. So how will you do that? For error measurement, this was the concept. Now let's see how do we get -0.2 or plus 0.2. How is that calculation done? How do we do that calculation? So this is my main scale division power. This is my vernier scale division. Okay. This is something. This is 1. This is 2. It goes on, but for vernier it is always fixed one. Here we have this much. How do we measure error now? In this case, in case of negative error, I'll take positive error first because that is easier so that you will not confuse. So this is slightly ahead. Okay, we take positive error. So in this case, we will check again vernier section. Which of the lines is overlapping? Okay, which of the lines is overlapping out of those 10 lines? So in this case, this is 1, 2, 3, 4, 5, 5th one. Okay, so let's say whichever it is, 5th one, 1, 2, 3, 4. So we fourth one, sorry, 1, 2, 3, 4, fourth one. So we call this fourth one multiplied by we know what is my LC? 0.01. So my error is how much? 0.04. Positive error. Okay. Very easy in case of positive error. But in case of negative error, how do we find out? In case of negative error, let's say something 0 is behind, there are, this is 10, but I'm just randomly drawing. So do not count it also. Let's say this one coincides in this case. Negative error thing. In such cases, in negative error, we again see which one is coinciding. Which one is coinciding? Let's say this is 1, 2, again the fourth one. But how is it different? We do not use fourth one. We see this is fourth from ahead, but from backwards, its position. What is its position? 6th one. So instead of writing that, we say 10 minus 4. So if it is fourth one, we write 10 minus 4 into 0.01. And what is my answer? This is 6 and 0.06. Is this clear to you? So I choose the first one because that one had, we directly take fourth one multiplied by this and we get the error. In the second one, it is different. Let's take Selena again and if we can
vernier scale and the main scale, they don't have an intersection line.
It's not possible. It is designed such way that each one of the line has to coincide. It is designed in such a way. The whole idea, like how it is done, is also given in your textbook. But if I go into that, I already see blank faces. It will be completely blank. I at least want you to understand some bits and parts so that we can, when we go to depth, you know, we think. Let's learn ABC first and then CAT as well. Okay. When they have given the answer itself. Okay. So instead of looking, please do not look downwards. Just check the diagrams. Figure 1.2, figure 1.5, and see what is the answer that you are getting for the. Then they have given the answer also, but see what we studied over here. If you can put the logic there. Negative error and positive error, page number 13.
What we have to do?
Positive error and negative error. See, in positive error, 0 should be ahead of PHY. So it is ahead, right? In positive error. In positive error. Are you looking at the figure 1.4?
Also coincides with 0.6.
Yes, it is point. We do not say 0.6. Is it 0.6? No, it's the sixth division of Vernier scale. And Vernier scale का unit क्या है? Yes. नहीं. Vernier scale का least count 0.01, right? So my
0.6 millimeter.
please do not play with millimeter and centimeter. We'll stick to centimeter only. 0.06 is the answer. So you see, in this case, 0 is slightly ahead. The Vernier caliper 0 is slightly ahead. Do not look at the answer. And you see, yeah, the main scale 0 is slightly ahead. Then the main scale 0. And we see that the sixth division of Vernier scale, reaching a Vernier scale for sixth division, is exactly coinciding with the topmost, whichever it is. We don't care. We just look at the Vernier scale.
So upper divisions are not mainly.
Main scale.
Main scale.
Yeah, they are main scale. So my error is what? It's the sixth division. And what kind of error it is? Positive. Because it is slightly ahead. So my error is plus 0.06. Is that clear? If in the same diagram, I will give you the coinciding division, you give me the answer for in the same diagram. If my coinciding division is 3, what is my error?
0.0.
0.0. If in the same scale, this one, my coinciding division is 9th one, then what is my error? 0.09. Okay. Let's move to the next one, which is negative error. Negative error is figure 1.5. Can you see it? And now we see clearly that 0 is coming first. The 0 Vernier scale is coming first, then the main scale. And here the coinciding division is again 6. But do we take 6? No. We see from behind its outward position. So total how many? 10 minus 6 is what? 4. And 4 multiplied by what do we do? LC. What is my LC? 0.0. So what is my answer? 0.04. And answer is the minus 0.04. I just say that's my negative error. But to the final answer, what do I do with my negative error? We add. That's the whole thing. That's the whole thing. What did we do here? If it is PHY, it was PHY. My answer is a negative, right? My answer is a negative. But since it was PHY, that extra, it's covering less distance. Yes, it is giving me measurement. No, it's not covering the less distance. What it is doing
Then
is
the actual, so we have to add it.
yes. So okay. So what it is doing is, please remember this thing why we are doing Yogita. Just I already told you, right? In this case, if this 0 was pointing after measurement, if this 0 was pointing at 1, right? Then it will cover how it has passed from this position and it's to move and reach 1, right? It reaches 1, but how much distance does it cover? It covers this actual 1 centimeter plus this much also because it was slightly pitched and extra mehnat karna padta hai. We just say that negative sign only shows that he is piche khada hai, right? But while walking and reaching that position, he has to do what? Extra mehnat. He is doing extra mehnat. If you are getting confused, let's not do it. Let's not even understand. Let's just remember negative error for final answer you have to add. And positive error For final answer, you have to subtract. Is that clear? For sure. And which one is negative? If you are behind. If BS is behind, right? Which one is positive? If BS wala is again. If the 0 is out. I'll be taking some questions for this in next class. Make sure you go through it, write it in your own words and understand, because we have a lot to cover now. Okay. And I think we only have 2 more classes. I want you to understand this part. Thank you so much.
What is the distance of light covered in 1 second?
Of light. What is the distance covered by light in 1 second? Does anybody remember? 3 into 10
3 into
power
10
of 8.
power 8 meter per second.
Okay, 3 into 10 to